Hello everybody, and today we are going to make a McDowell's moving ball maze. So McDowell's, from the famous movie with Eddie Murphy in it, Coming to America, where they had McDowell's as a competitor to McDonald's. And McDowell's, well, sounds like McDonald's, but is completely different than McDonald's. McDonald's has the golden arches, McDowell's got the golden arcs. McDowell's, what else do they have? It has the Big Mac, and McDowell's got the Big Mick. There was a couple of other slightly big differences, but anyway, so we're making a toy for inside the McDowell's Happy Meal. So that's where we're going to begin. So we're going to start with the base, make all the other components, and I'll show you how to print it using Kiri Moto so you can print your own at home. All right, here we go. So we're going to get into it. So the moving ball maze, if you remember, as like a real little kid, you had like a little steel ball inside the thing, and you move it like this, like one of those pictures that's floating around on there. Pretty cool. Sometimes they were like pretty small. These are 3x3, which is the same size as a Post-it note, and you'll see that comes in later. Enough of that. Let's get going. So first thing you do is you're going to open up Onshape. So we're going to use Onshape, the 3D model, and use Kiri Moto to 3D print, which is within Onshape. So I'm going to create a document. Inside that document, let's do McDowell's Maze 2, because the first one I recorded the wrong screen for about 20-25 minutes. So now I got to do it again, which is fine. Here we go. Practice makes perfect, I guess. All right, so we're going to create a sketch on here, and we're creating the base within the constraints of the drawing that I have up. So here's a picture of the drawing. It's also going to be in the link to the description of this. So if you're using this in the classroom or you just want to make your own, there it is. So I'm just going to make sure that I have it up. And I do. Whoops. Right here, and we're going to start with a 3x3 center point rectangle. So I'm going to create that sketch on there. I'll hit N to bring it in, hit the drop down next to here, center point rectangle. Boom, 3, tab, or 3, enter, 3, and there we have it. From here, we're going to extrude this out 0.5 inches. So we're going to come over to here, type 0.5, enter, and that's it, done. So now I'm going to create a sketch on here, and what we're going to do is recess this in now with the little radiuses in the corners for the holes for the screws. So I'm going to basically hit N again, hit U on the keyboard, select the whole surface. From here we're going to do offset. Click that. We know, when we hit enter, that now we get to put in the dimension of 0.118. That is the thickness of the outside wall. Click enter. From here, we're going to do circles on every single corner, and I'm just going to draw them in, click, while I'm clicking. You could pattern this if you wanted to. I'm just then going to hit D for dimension. I know the radius is 0.098, and I'm going to do, since I need a diameter for a circle, hit 2, and that's it. And I'm going to do that for this one, and I know what the math is now, 0.196. I'm sure there's an easier way to do this, but since there's only 4, you're not saving much time. Hit the check mark, and you are good to go. We are going to extrude this down now, according to that diagram, 0.315 inches, which gives room for that 7mm sphere that we're using in ours to roll around. So what I'm going to do, remove 0.315, enter, check. And there we have that. Now this is part of the basis. What I'm going to do now is turn the sketch on. I have points that I can use to make the holes that's going to use for the screws to hold the top in. Come up to use the hole tool right here. And I'm going to click 1, 2, 3, 4. The hole itself is 1.5 millimeters. It's going to be a simple blind hole. So that means with a blind hole, you drill down and there's a bottom to it. We're going to use blind, and that's going to be a depth of 8 millimeters, like it says on the drawing. It says typical, so that's all 4. For the bottom, I'm just going to use flat. Nice flat bottom. We're 3D printing these. We don't need a conical or any sort of pointed bottom. Hit the check mark. Holes are done. We can turn off that sketch. Now, everyone that in my class is going to have that same exact base. It's what's on their Post-it note right here that they're then going to use to make their actual maze. So what we do is we're going to take a Post-it note, 3x3, draw it a 1-to-1 scale of what our maze should be. Now, a 7mm ball is about the thickness of a pencil. So if you take a pencil, which I don't have anywhere near me, and put it in the little spaces for the maze, it should check out to be enough space to allow the 7mm ball to go through. So let's bring that image in. This is a pretty cool part because now you don't have to try to guess what's going on. You can bring your image right in. So I'm going to go Sketch. Click that right there, that bottom face. Once I do that, I'm going to come over to here and hit Insert Image. So Insert Image. I'm going to import in my maze. And I think it's that one right there. Looks like it's got it. I click it over here. I'm going to hit N. It says Draw Image Rectangle. I'm going to start at the top corner here roughly. It does not have to be perfect. Right? Now I'm going to bring it in a little. And there it is. So now I have a reference, something to draw on to make the rest of this. The walls for our maze inside need to be at least 2mm. That'll be enough for the printer to give a nice shell as it goes around and print, and usually not have to put infill. Now I'm going to come here. I have a couple of parts. I have a start and end stop. I'm going to put them in first. And right here, it's 7mm ball. I'm just going to make it 7mm. That's one divot. I'm going to do a start divot over here. 7mm. So I know that my sphere is going to fit into them. Also, with this circle, I now know I can drag them around to make sure that the ball is going to fit in all the single spots that I have. I'm going to use corner rectangles, and I'm going to start here, and I'm going to come up. That is 2mm. I'm going to leave the height as is, and I'm going to start coming through. Now notice I'm deviating a little bit from my sketch. It's fine. The sketch was a guide. That's all that it was. Oops. And 2mm. There we go. And I will come in and continue drawing 2mm walls all the way around. And if this is boring, you can either suffer through it or fast forward. Whatever floats your boat. And it is getting slow. There we go. 2mm. I'll show you something else. Enter. 2mm. Now I can tell looking at this, if I bring this over, right, it's not going to fit. So I'm going to drag that side down. Like that. And there it is. Now with this one, I do have a movable component that I am not going to worry about for this tutorial. If you're making a spinner, you make a spinner on your own. If you're making a block, to block things, you can do that on your own as well. That's where they would be. Like I said, for all intents and purposes, this is what we have. Over here, I'll simplify this a little bit. Come on, switcheroo. And let's see, maybe I will do one here. That. Notice the change of that wall. So what's going to happen is I added a constraint in, so it's going to move it like that, which is fine by me. So now this is my maze. Real simple. It's not the exact thing I had, but it's a gauge. It's something to help me move quickly. I can drag this around to see if it fits. So it looks like it's good, good, good. All right, a little tight over here. That's fine. It should make it through. Looks like this. Now you should be a little more careful doing this, and it's going to squeak through over there and come through. Just to make sure, I will drag this in a little more, and that's fine. Now I give myself a little space. I can just move some of these over a little bit just to give a little more room. That's good. Like that. I think we're fine. Let's double check. Good. Now, yeah, there we go. It's pretty good all the way around. Okay, so that's part of the maze right there. I'm going to finish sketch. And I'm going to extrude those. Don't worry about the divots. We'll get back to them. We'll extrude those up. 0.315, the exact opposite number that we extruded down by before. I will do add, merge with all, just in case, enter. There's my maze. Now, to bring those divots back up, you're going to turn the eyeball on over there, extrude. We're going to remove 0.05, I feel is a good number. I like that, which is 5/100ths of an inch. Check that. And now I have my divots. Let's turn off the sketch. And there we have it. I tell my kids that they have to put their name into it. So let's find a spot to put our name into it. I'm going to create a sketch up on this top. Hit N, that recenters it. Come over here to the text tool. Just going to put I wish I could spell my name. There we go. Mr. Stano. Check. There we go. And I select that. Remove. We'll do the same amount, 0.05 down that we did before, because I like that number, and that's it. You can put your initials, your name, or not. If you're not in my class, I don't care what you do. But if you're in my class, put your name on it. So when it prints, I know whose it is, because I don't pay attention. No clue what's going on at most points of my day. Anyway, so there you have it right there. That is the maze. I don't like this blue. Let's edit the appearance. I like orange. I've been stuck on orange today, so I'm leaving it. And there you have it. Now, if you're making a movable piece, you can make that's a separate part. You'll put it in the assembly. We'll go through that in a little bit. Now, let's go do an assembly, because we're going to create everything from the assembly. Okay. We go to the assembly. We are going to insert this in. Hopefully you know how to do this. Click, hit that, check. All right, now it's in. We are going to fix this part. Fix, so that it does not move. We don't want it to move. We are going to design the little clear top that goes on it. It's a 1 millimeter thick clear plastic piece. That's all that it is. To do that, I'm going to do that in Studio, Part Studio in context. Click the origin, hit check. And now it's going to do some magic. It's going to bring it in. Change it. Sometimes you don't see it. You got to move this around. I'm going to create a sketch on that surface there. Hit N. Now I'm going to hit U. I don't want all these lines. Sometimes it gets a little finicky and it's going to select everything. But if you're good, you want to select just the outer lines and just the circles if you can. Like I said, sometimes it gets a little finicky. Check. Now I'll be able to extrude. Let's see if I can turn that all the way down. Just this. But you see it's also selecting everything underneath. Oh well. Extrude. There's everything, but I'm going to select that too. So that's my clear plastic. Like I said, 1 millimeter. You have to type in the mm. That's it. Check. That's a new part. We're going to edit the appearance. Where'd you go? Edit appearance. Edit appearance. I'm going to do a light gray, and I'm going to take this little slide bar and set the transparency all the way down, or pretty far down. Hit the check mark. Insert and go to assembly. Check. There it is. This top will move. We don't want it to move. So I'm going to fasten it into place. There's a couple of spots you can fasten it. I'm going to show you where I'm going to fasten it. Fasten mate. I'm going to use the bottom of that bolt hole with the top of that hole, and I'm going to hit check. That top is now in place. It's fastened. I like that spot. You don't like that spot? You can fasten it somewhere else. That was an easy one for me. Now we're going to bring in some content. The content that we're going to bring in are the little screws. You don't have to model them. We're going to bring them in from somewhere else. Insert. Standard content. Remember, we're doing this in the assembly. When you go to standard content, we're using a very specific screw. It's an ISO screw. It's metric. So we go to ISO, bolts and screws, cross recess head screws, pan head screw, ISO 7045. It's an M2 size. That's the size we're using. 6 millimeter length. Thread is 6, and it's stainless steel. You will click insert, and you are going to insert 4 of these in. There you go. Notice it's also got a part number. Check. We will use a fasten to get these in. Come on. Check. And you will work your way around, selecting these little spots. Notice there's a chamfer on it. Listen, will I know if you don't get it in the perfect spot? Never. Maybe you didn't screw it down all the way. Maybe you did. In real life, it's fine. Check. Come do the last one. Check. Good. Now the screws are in. The only thing we're missing is the little sphere. That's a 7mm sphere. Let's make that. We are going to, we'll just make a 7mm sphere. We don't have to do it in context of anything. So I'm going to create a Part Studio. Now I got a bunch of Part Studios here, so let's rename some of these. Part Studio 3 is sphere. Check. Part Studio 2, glass cover. So I right click on it, glass, or plastic, whatever you want to call it. Part Studio 1, right click, rename, base. Done. Let's just go back to sphere, create a sketch on that plane, hit N, create a circle of 7mm in size, 7mm, check. Now, we're going to use a revolve to make this, and because we're using a revolve, we only need a half circle, and you can leave it just like this, hit the check, revolve, that side, revolve axis is the line you made, check, done. I will change this, edit appearance, to be a dark gray sphere. That is done. Now I go to my assembly. I will turn off the visibility on the glass. I'm just going to use a tangent constraint somewhere on here. Let's insert current document, sphere, right there. Good. Check. I'm going to use this tangent mate right here, where I click the surface, I click the sphere, and I hit check. Now what you'll notice is that the sphere always stays tangent. So if I go to the top view and drag this around, it can fit into a divot, it can come around, it can go around, up and down and around, and always stay on that surface. I will turn the visibility back on with that, and that is a made, assembled McDowell's ball maze. The last thing we need to do is 3D print it. Two ways to do it. One way, super easy. Other way, a little bit of work, still super easy. The base is what's 3D printed. Come over here. If you just need the STL because you're using your own slicer, right click, export, STL, you'll change it to. File name, whatever you want. Format, binary. Units, millimeters. Don't ask me why, just is. Resolution, fine. That's what I can do it. I normally do it medium, but I'll do fine for this. I'm going to use on my own 3D printer. Options, download, export. You see down over here, there's your STL. Done. That's the easy way. So if I'm saying, hey, let's use the MakerBot, I want an STL, give me the STL, that's how you do it. Second way, Kiri Moto. If you don't know what Kiri Moto is, it's the CAM software that's used by Onshape to 3D print stuff. Applications, Kiri Moto. If you don't have it, you're going to go to the App Store. And when you go there, you are going to go to CAM. And there it is, Kiri Moto. Now when you do this, you can subscribe to it. So you'll do that. And then it's going to ask you a couple of things. You'll need to refresh your browser when using Kiri Moto. And then it should open up. So enough of that. Hit the plus sign, go to Applications, Kiri Moto. Now I will hit the X. I did this before because I filmed it and captured the wrong screen by accident. I'm just going to click on that and delete it. Come on. Why it's not? I don't know. There we go. See a trash can? Delete. Now I'm going to go import base. There's my part. Click it in. That's in. Some of your screens may be different depending on your machine. If your machine, you know what machine you're using, go to device. I'm using a Creality Ender 3. So you go to FDM, Creality Ender 3. You can change any of these if you want, the macros and all this stuff. That is completely up to you. You don't need to. All right, hit save. And X. So that's there. These are the recommended settings that I use with my Ender 3. You'll know yours better than mine, but if you're in my class, these are the settings to use. Layer height, you're going to change that to 0.22. Leave the rest alone. Base, change that to 0.22. Leave the rest alone. Infill, I do a hex pattern. I actually don't care what pattern you use. I use hex for this. Fill fraction 0.2. That's a 20% infill. Could you use more? Yeah. Do you need to? No. You could actually probably get away with 10%. I like 20%. Leave the rest alone. Support, no support with this. Nice project to print. Output, these I need to change. Nozzle temperature 210 degrees Celsius. Bed temperature of 60 degrees Celsius. Fan speed, leave that alone. Print speed is the other one you're going to change. I would change that to 75 using a Creality Ender 3. If you want to go faster, you can. For us in class, I do it at 75 to 80 millimeters per second. The rest is pretty much good to go. And you will go start, then slice. And now you'll get to see what the 3D printer does. It's going to slice the software. We got 56 layers. Let's zoom in. And you can see how the infill pattern is, what it's printing, the infill there, and that is it. I then go to Start, Export, and this is where it's going to give me the downloadable G code that I need. Change my file name to Maze 2, the second one I've done. Shows me in file size, 2 hours, 24 minutes to print. It tells me that I'm going to use 119,000 millimeters of filament. And the printed weight is 36 grams. Great. Download that G code. Shows up somewhere on your thing, on your computer, and that is it. That's how you set up the CAM software to print. X. I'm going to go back to my assembly, look at it, and go, great. So that is how you are going to 3D model and print and do everything else that you need for your McDowell's ball maze. What I'll do is I'm going to take a link to the assignment and I'll put it in the comments so that if you want to use this as a classroom or you want to see what I'm using to do this, it'll be there and a link to a Google document. That's pretty much it, I think. The screws I got on Amazon, the clear plastic or transparencies normally I use, but if you got a little bit thicker material, that's a little bit sturdier, great. That's what I had around it at the time, but they work pretty good. There's a picture somewhere, or there was a picture in the beginning. I don't know, you know the little thing that moves. If you have any questions, please put it in the comments, I'll answer them. If you like this video, please like it and subscribe it. Why not? And if you have any other questions, please let me know. All right, everyone, that is the McDowell's ball maze. Remember, it's the golden arcs, not the golden arches. Have a great night. Bye.